So for this example, we have x squared plus 4x plus 11 is equal to 0. Currently, that quadratic is not a perfect square, so we need to subtract the 11 to the other side first so that we can make it into a perfect square. So we will change it to say x squared plus 4x. We're going to leave a blank spot there so we can add on what we need to add on, is equal to negative 11. Now, to make this into a perfect square, we would have to divide the 4 by 2 and square it. So 4 divided by 2 is 2. 2 squared is 4, so we will add 4 to both sides of the equation. X squared plus 4x plus 4 factors into a perfect square, and this factors into x plus 2 squared. This will then equal negative 11 plus 4 is equal to negative 7. So now I could take the square root of both sides. The square root of something squared is just that something, so x plus 2 is equal to the square root of negative 7 would be plus or minus. We're dealing with the square root of a negative, so that means I, and then just the square root of 7. So this gives us x plus 2 is equal to plus or minus I times the square root of 7. Now to get the x alone, we would have to subtract the 2 over. And we would just place that right out in front, so our x is equal to negative 2 plus or minus I square root of 7. And that's our final answer. Alright, we're going to look at another example. Number 8 says x squared plus 2x plus 6 is equal to 0. So once again, on the left-hand side, that quadratic is not a perfect square. So we are going to have to subtract the 6 from both sides, making this x squared plus 2x is equal to negative 6, leaving a blank spot in so that we can complete the square. To complete the square here, we would add 1 to both sides. 2 divided by 2 is 1, 1 squared is 1. So now this will factor to x plus 1 squared. Is equal to negative 5. So now we could take the square root of both sides. The square root of x plus 1 squared is x plus 1 is equal to plus or minus I times the square root of 5. Now to get the x alone, we would have to subtract 1 from both sides. So our solution here is negative 1 plus or minus I root 5. And this problem originally would be unfactorable. Last problem, we've got 2x squared minus 5x plus 3 is equal to 0. Now this problem is drastically different than the other ones that we've done. All the previous problems, the coefficient in front of the x squared was a 1. So it worked out nicely. This time, the coefficient is a 2. That's not going to work out so well for us. So we need to figure out what we can do to this equation to get rid of the 2 that's attached to our x squared. There's two very viable options here. One of them is to divide both sides by 2. And the other one is we could pull it out of there as a GCF. I prefer dividing everything by 2. So when we divide by 2, we have x squared minus 5 halves x plus 3 halves is equal to 0. Because 0 divided by 2 is 0. And now we do the same process we did before. So we're going to subtract the 3 halves from both sides, which leaves us with x squared minus 5 halves x, leave a blank spot, and then is equal to negative 3 halves. Now we need to figure out what we would have to add on to complete the square here. Well, 5 halves, we have to divide that by 2. Dividing by 2 is the same as multiplying by 1 half, so that is 5 fourths. 5 halves times 1 half is 5 fourths. So we divided it by 2 to get 5 fourths, and now we need to square it. Well, 5 fourths squared would be 25 sixteenths. So we'll add 25 sixteenths to both sides of the equation. The nice thing about writing out that information up there when we divided it by 2 is we now know what the perfect square is for this quadratic. It's just x minus 5 fourths squared. Because that 5 fourths is what 5 halves divided by 2 is, and it's also what the square root of 25 sixteenths is. So we'll change this to say x minus 5 fourths squared, and it's a minus sign here because we have a minus 5 halves x. And then is equal to, now we need to figure out what negative 3 halves plus 25 sixteenths is. Well, we're going to need a common denominator, so we can change the 2 into a 16 by multiplying that fraction by 8. So if we take negative 3 halves times 8 in both the numerator and the denominator, we end up getting negative 24 sixteenths plus 25 sixteenths. Well, that's just 1 16th. So we have x minus 5 fourths squared is equal to 1 16th. And now we can take the square root of both sides. So this then gives us x minus 5 fourths is equal to plus or minus, and the square root of 1 16th is 1 fourth. So now we have to take a positive 1 fourth and add our 5 fourths to it. And then we'll also have to take our negative 1 fourth and add 5 fourths to it. Well, 1 fourth plus 5 fourths is 6 fourths, which reduces down to 3 halves. Negative 1 fourth plus 5 fourths is 4 over 4, which is just 1. So our solution here is 1 and 3 halves.